Hello guys and welcome back. So today's question is from IMO 2020. This is an IMO PYQ, and yet again we are back with the 100-day JEE Advanced question series. So guys, today's question is a really good question because this question doesn't need too much of mathematical, I would say, solving. It just needs your understanding. Okay, this is a very good conceptual question, I guess, so I decided to bring this in. So guys, this is actually taken from a PDF made by Ayan Khan. I have attached the source of the PDF in the description, sort of like the name of the person who has made this PDF. I have taken it directly from there. So this is a good question, guys. Just try this question out. I will wait for a few seconds. You can pause the video and try this out. I will wait for a few seconds and then start off solving this. Okay, guys, I guess now it is time for us to solve this. So first thing is, let's have a reading through the question once. So there is an integer n which is greater than 1. N greater than 1. And there are n square stations on the slope of a mountain. So there is a mountain like this, maybe, and there are n square stations like this. I know my diagram is not at all good and very real world representing, but still. Okay, there are n square stations on the slope of a mountain, all at different altitudes, and each of two cable car companies A and B operate K cable cars. So there are two companies, A, comma B companies, and these operate each K cable cars. Okay, so each cable car provides a transfer from one of the stations to a higher one with no intermediate stops. So let's say if we try to number these stations like 1, 2, 3, 4, 5 till n square. So the meaning of this thing is it can transfer you from 1 to 2, it can transfer you from 1 to 3, it can transfer you from 1 to n square. But it can't transfer you from 2 to 1, 3 to 1, 3 to 2 and so on. Okay. And one more rule, if it transfers you from 1 to 2, then there are no intermediate stops. But say it transfers you from 1 to 5, then for that it will never stop at 2, 3 and 4. It will keep going, and until and unless it reaches 5, the cable car won't stop. Okay. So after that, the K cable cars of A have K different starting points and K different finishing points. So K cable cars of A have K different starting points and K different finishing points. I am writing this as S and F. Okay. And a cable car which starts higher also finishes higher. Meaning a cable car which is like, say if we take two cable cars, one starting from 2 and one starting from 3, then the cable car starting from 2 will, if it, I mean not will, if the cable car starting from 2 it ends at 4, then the cable car starting from 3 has to end at 5. Okay, so a lot of conditions have been given. The same conditions hold for B. Okay. We say that two stations are linked by a company if one can start from the lower station and reach the higher one by using one or more cars of that company. No other movements between stations are allowed. Okay, that means we can travel only using cable cars. So we have to determine the smallest positive integer k for which one can guarantee that there are two stations linked by both companies. Okay. Okay, so this was the overview of the question. And guys, one more thing, like you might be wondering if such complex sums would ever come in JEE Advanced or not. So see, a clean sheet answer will be no, because these sums are like too difficult for JEE Advanced. But see, one thing is that permutations and combinations is a chapter on which JEE Advanced doesn't go too much out of range, hasn't gone still. Once it went, but after that they have almost stayed in between what is the normal range. Okay, normal range meaning whatever we mostly do in class and we are capable of solving only with that. But if someday, because permutations and combinations has almost everything except a few high level topics, so it's of no surprise that someday a question of this level might come. And also, like, if you want to study and understand permutations and combinations in depth, you need to learn a lot of things. Okay, anyways guys, without further ado, let's start off solving this. So guys, this was the overview of the question. I hope you understood. So what I'm going to do is I will write most of the things, okay, in statements, because it's a PNC question and I am not teaching you in front, so maybe that would have been better. But here I have to write statements, otherwise there could be a problem in understanding. Okay, so let's start off. First thing, I will give you a small overview, okay, and I will also show you a small diagram so that you can understand. So first is, think of each station as a vertex. Okay, I will show you the diagram and you will understand what I mean by a vertex. And each cable car as a directed edge from start to the higher finish. And guys, I am going to write a whole lot of things here, so please do have patience, because otherwise this will be too difficult for you to understand. Okay, the solution is pretty simple, but understanding this needs some time, so please bear with me. Okay, so for one company, first point is every station, like I am writing a small overview of what is given, can be the start of, just note this, at most one car. Okay, that was what was given in the question. And finish of at most one car. Why? Because starts and finishes are different. Okay, I hope this has no confusion. So this was the first point. Now write down a second point. And the second point is because I'm also trying to write fast so that we can skip off this writing part a bit earlier. Because every edge goes from lower altitude to higher altitude, there can't be a directed cycle. Now, what is a directed cycle? Directed cycle basically means that it is not predetermined from which station to which station it will go. Like, there's no perfect pattern. Okay, that's what is the meaning of this. So each connected piece is just a directed path, or you can, like, in simple words, you can say it is just a chain. Okay, so some paths can be length 1 and many others also. Like, we don't quite know what is the value of n square because there are n square stations, so it could be 1 2 3 4, whatever. Okay, okay, so just one final thing, two stations are linked by a company if the condition given they lie in the same path of the company. Okay. So this was for whatever information was given, and it's crystal clear, I hope, right now. So guys, after this, we will now delve into the deep dive into the question. Okay. So let's take a key count. Okay. Key count meaning I am taking some variables. Say if a company uses K edges. Okay. I hope you remember what the meaning of edges is. Each cable car that's why I wrote at the beginning. Each cable car is a directed edge from the start to the higher finish. Okay. I hope you understood this. So if a company uses K edges on capital N stations, then number of paths or components. Like this is very easy to say, I guess, because this will be capital N minus K. Because total on the path there are capital N stations and we are using only K stations out of them. Okay. I mean K edges, meaning we are actually using K cable cars. So number of paths, like it's a one-way path, right? It can't go down. It can only go up. So things are always one way, lower to upper. So that's why if things are one way, then K cable cars can follow K paths only. So it is N minus K. I hope this part was clear. Okay. So for the time being, let's leave this result here. We are going to use this later. Okay. Once for capital A and once for capital B company later on. Now just look at this. Label the n square stations which have been given to us on the slope of a mountain by grid coordinates. Now what is grid coordinates? Basically grid coordinates is like you can consider it as your x comma y. Grid coordinates is actually a term which is used in contours. Okay. If you have read geography in your maybe childhood, then grid coordinates is actually used in contours. There are a lot of like different coordinate systems, 3 4 points come in, but grid coordinates, you can say it's a basic term for a coordinate system used to mark locations. Okay, that's why I have mentioned grid coordinates here. Okay, so label the n square stations by grid coordinates I comma j. You can just don't like go into any complexities regarding this thing. Just consider it as a point x comma y. Okay. For your I comma j belonging to, I hope very clearly, 1 till n. Okay. So if we now try to order the altitudes lexicographically. Now if you want to know what is the meaning of lexicographic, I hope you know. Or if you want to know what is the meaning of lexicographically, it actually means dictionary order. Okay. Lexicographic is actually something you have seen in basic questions of PNC, dictionary order. But here I am trying to use lexicographic word in a different sense. Actually here what I mean is, like maybe I can give you an example. Say if I comma j, okay, this thing is lower, wherever I write lower or higher, it is always in altitude. So if I comma j is lower than your say I dash comma j dash, then it is either I less than I dash or I equal to I dash, or okay wait, I equal to I dash or I less than I dash or I equal to I dash with j less than j dash. Okay, now try to understand. Basically what I'm trying to say is your x coordinate can be same, x coordinate can be different. If it is different, then in this particular example that I have written here, the first point's x coordinate will be less than the second point's x coordinate. But this equal case can happen only with the abscissa. For the ordinate, it will always be less than. Okay, that's the clinical meaning. You can take any, like from this definition, you can take any example that you want. You will automatically understand. Okay. Okay, so now I guess let's start placing the cars and see what number of cases we get. So let's say for company number A. Okay. So for company A, let's take, like, I'm taking a general point as I comma j. So it is basically, you can consider it as I rows and j columns. Okay, try to understand. Because I am taking it in a 2D coordinate system, so I am like mentioning x and y coordinates as rows and columns. Okay, I hope you have understood. So in company number A, in each row I, we put the cars. You will understand how. So basically here in each row I we put the cars, means I, the x coordinate remains constant, we keep changing the y coordinate. So I comma 1, after that you will have I comma 2, similarly I comma 3, and this will go on till your I comma n. Okay. So if this is I comma n, I guess if we try to count the number of cars, total number of cars in each row. Okay. So after this, guys, like this part, try to understand properly. Okay. This might confuse you a little bit. So, okay, let me first write. Then actually you will have the confusion, and after that when I explain it will be clearer. So guys, from here actually, what you will realize is there are n minus 1 cars per row. Or if I write it in a better way, as per our language that we introduced in the beginning, it is n minus 1 edges. Okay. So now you will understand, you will have a question immediately that 1, 2, 3 up till n. So how is it n minus 1? So basically, a cable car connects two stations, and edges that we are counting here is basically the paths that we are counting. Okay, n minus 1 cars per row here basically means the, see, n minus 1 cars doesn't mean number of cars. N minus 1 cars means one car traveling from one place to the other. So I am trying to denote one path. Okay, that's the clinical meaning of this language. So if I go from I comma 1 to I comma 2, it is one path. Similarly, from I comma 2 to I comma 3, it will be another path. So if you actually take one path systems, you will have n minus 1 paths. Okay, one path systems. So after this, if we try to total the total number of edges, or total number of paths also you can say, if you don't want to complicate the language, then this will actually be n times n minus 1. Why? Because for each point, 1, 2, like, see, for each point, this was one explanation, but if I want to explain the total thing, then better is for I comma 1 point, you can go to I comma 2, you can go to I comma 3, and you can go dot 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 till your I comma n. Okay. So that is n minus 1 paths for one point, and there are n such points. So it is n into n minus 1. Okay. I hope this was clear. So that means we will have n square minus n total number of edges. N squared minus n. So in a very similar way, if we go to our company number B, and here I hope we have to do the placing in each column J. Okay. So here actually it will be 1 comma j, 2 comma j up till n comma j. So very simply, perfectly similar explanation will give you the total number of edges here also as n square minus n. Like, I hope you can understand, right? Because here also you have n points, and for each point you will have one path, and total one path to the next point, and such total you will have n minus 1 paths. So n into n minus 1. I hope up till this everything is clear. So if we now proceed into our sum, like the sum is not still done. So if we try to proceed now. Okay. So guys, after this actually, I will write another statement. A pair of distinct stations. Like, I hope you have heard my explanation of the question well, okay? Because see, this question contains a lot of data. So if you haven't heard that well, just go back to wherever time I was speaking that and listen to that once, because otherwise you will get pretty confused, okay? Like, you will not understand what I'm writing. It will seem pretty irrelevant, okay? So a pair of distinct stations can't be on the same row and same column. Okay, this was given in the question. So actually, with k is equal to n square minus n for each company, like what does the statement I wrote here mean? With k equals to n square minus n for each company, like that is A or either A or B, there needn't be any pair linked by both. Okay, now see. Thing is, when we were actually counting, like I will come back to this part, when we counted our company number A case and B case, you can see the points in front of your screen, right? We kept I and J fixed, but I and J's values weren't introduced in our counting. So when we introduce the values, actually what I have written here will come out to be true. Like, there should not be any pair linked by both, but we haven't introduced the values of I and J. So basically, in very simple words, if I try to say, if A and B are like A and B are two cases, then I comma J, the values on getting introduced, there will be a wide number of intersections. Okay, wide number of intersections, and we don't need intersections because we don't need any pair to be linked by both. That is our condition in the question. So actually the minimum value that was asked to us, the minimum value is actually to signify that, like, see, our answer has already come, but still we have to introduce this condition into the answer. And we don't actually need also how many cases are the intersections, because we have been asked the minimum value. Okay. So now I guess if we try to write our k minimum, this will be nothing but I am putting greater than equals to n square minus n and plus 1. Okay, I hope this was clear. Okay, so actually here you might have a doubt now that where did this plus 1 come out of the blue. Okay, so listen carefully. I will just read out the final statement of this question once. So final statement was, determine the smallest positive integer k for which one can guarantee that there are two stations that are linked by both companies. Two stations. Mark it. Okay. It is which one can guarantee that there are two stations linked by both companies. Now, two stations, any two stations can be joined by one path. Or rather, in the language of our question, like whatever we have used, in that language, one edge connects two stations. Okay. So this plus one introduction here is actually breaking the minimum boundary. Like, see, up till the point where k was equal to n square minus n, up till that point, it was like k's value is equal to n square minus n is still just enough to avoid a common linked pair. Okay. I hope this was a clearer statement. K is equal to n square minus n will be still just enough to avoid a common linked pair. But we don't want to avoid that. We want the minimum value of K such that a common linked pair appears. That is, connection of two stations appears or an extra edge appears. One extra edge. Okay. So actually this plus 1 is being enforced because we have studied this and found that this k equals to n square minus n is the minimum value for which it is avoiding a common linked pair. So introduction of a plus 1 will actually break that. So a plus 1 will be the minimum value. That is the explanation. Okay. I hope this was clear. And if you have any more like questions in your mind still, don't worry, I am not ending this here. I will go into a like further study of this and I will prove that this is correct using inequalities right now. Okay, so let's proceed with that. Okay guys, so before actually proceeding, I thought of showing you another diagram for n equals to 3. Okay, a small case so that you can have an idea of what is going on. Okay, so here's the diagram, and guys, here the red arrows are for A and the blue arrows are for B. Okay, so you can, I hope, see the diagram properly, and this is actually the case for n equals to 3. These 1, 2, 3 that you are noticing here, these are the stations. Okay, I'm circling them. These are your stations. Like this is shown in a square form of pattern, but actually it's not like that. It will be perfectly linear. But here the advantage of showing this as a square is you can get to know all the different cases. Okay, so these are the possible cases. So if you actually see carefully, like I don't think there will be enough intersections here. Like if we try to apply our formula, okay, n square minus n plus 1. So for 3, I hope k minimum comes out to be greater than or equal to 3 3s are 9 minus 3 6 plus 1 7. Okay, so we need to, I guess, see the seventh number station. So k minimum, k value, like the minimum value of k has come out to be 7. Okay, so that means after 7 edges you will actually get. So right now we, like, I haven't drawn the diagram in such a way so that I can show the intersections. Maybe if I had done that it would be better. But guys, this is the like rough scenario that going on. Okay, I hope you have a rough idea from here. So like don't worry, all the questions in your mind will be cleared right now because now I am going to prove with inequalities that this statement is correct. Okay, so let's move on to that. Okay, so for the time being, like, let's take our capital N to be n square and we will return to a very like good result that we found out in the beginning, and that is the number of edges or number of paths. Okay, capital N minus k, and here we are putting capital N equals to n square because that is what is given. So number of a paths, like company A paths, will be actually equal to number of company B paths, equal to capital N minus k. Okay, so like from here we are going, like from this part I will actually do an assumption. I will write that down. Like this is actually we are going to prove this by a contradiction. Okay, so let's assume for contradiction that no pair, I hope you know what a contradiction is, no pair of distinct stations are linked by both companies. Okay, which means that every, like, I'm not writing this, just hear me out. It means that every a path, it will meet every a path will meet every b path in at most one station. Okay, every A path meets every B path in at most one station. Why? Because if two stations they lie in the same A path, then also they would lie on the same B path. That means these two stations would be linked. Okay. So pertaining to this condition, let's try to now count the number of intersections. I mean the number of, not intersections, the number of stations which are arriving by intersections of the paths of company A and company B. The number of intersection stations, we try to count them. So intersection stations. So guys, I hope counting this will be pretty easy. So we know there are n minus k A paths as well as n minus k B paths. So total number of stations, I guess, if we take our coordinate system, it is A path, comma, B path. So I hope you can actually consider a square of length n minus k to n minus k. So I guess it will be n minus k whole square. Now see, this is not, I will not put an equal to, this will be your greater than equal to, because at most, okay, not greater than equal to, I'm sorry, at most, so less than equal to. Okay, max to max, this can be the value. Why? Because n minus k is the total length, so it can't be less than n minus k whole square. It will be at most, like it can be less than n minus k whole square, but at the most n minus k whole square. Okay, so we, like, this is our total number of maximum, at most the total number of intersections possible, but what we have is a capital N number of stations given. Now try to understand. Capital N number of stations are actually given to us. So if n minus k whole square is the number of at most stations, then number of intersection stations is this, which actually means that capital N has to be less than or equal to your capital N minus k whole square. Okay. Like, what can be the most adverse situation? Most adverse situation can be that all the stations are intersections. Okay. It can be a situation like if it is like both companies A and B are running similar, like all the trains running from, say there are three, I'm assuming something, say there are three main combinations of cable cars that can run: 1 to 3, 3 to 5, and 5 to 7. And A and B are running their cable cars in all of these three. So if they are running their cable cars in all of these three exact paths, then now both are equal. Number of edges are equal. That is what I am trying to say. Okay. Like, this is the most adverse condition, otherwise capital N will be always less than this. So this is our inequality, guys, and if we now go to solving a bit of this, I hope we can write root n, capital N is less than equal to capital N minus k, or from here k is less than equal to capital N minus root n. But we know that our small n square is present as capital N, so small k becomes less than equal to small n square minus small n. Okay, so this is the value that we got from our assumption. So if k is greater than or equal to n square minus n plus 1 from our last condition, then this inequality completely fails. We can't like judge only on the equality, right? We have to see greater than and less than also. So if k is greater than or equal to n square minus n plus 1, then this equality completely fails. And therefore, any common linked pair, even if at least one has, I will just go down, has to be present. Okay. Or in other words, no common linked pair in between A and B. This particular condition in this particular problem can't exist. Okay. It's impossible. You take you take any combination, you take any path, any edge, it's not possible. This is absolutely impossible. Okay. Like even if it is at least one, it has to be there. There has to be at least one linked pair, common linked pair in between A and B, and greater than that, it is possible. So that means minimum, like very much proved from here, okay? That K minimum has to be equal to n square minus n plus 1. Like even see, although this inequality is not true in terms of greater than and less than, but you can see if the plus 1 was not there, our k is coming to be equal to n square minus n, and that was the value we found above. Okay, not above, like in my screen it is above, but for you it is before. So guys, the answer for this question will be n square minus n plus 1. Okay, I hope no more doubts. So guys, this was like good magical question. Okay, this was a very good question. Like you saw, right? Not much of mathematics, pure logic, pure PNC. Because PNC is not about calculation, I'm telling you. PNC is not a chapter that is like, it's not, see, PNC and calculus are really different. PNC is much more different from calculus and algebra. PNC, if you go for pure difficult PNC, then these will be the types of questions where you have to analyze, where you have to judge things, where you have to solve small things and get the conclusions ready. Okay, like your conclusion should be false proof. Like the conclusion, the derivation of this I did right now, not derivation I should say, the answer I found right now is absolutely flawless. You go with any condition, it will always be true. Okay, so your answers to permutation questions should be such that nobody can find any exceptional case to this. Okay, anyways guys, this will be the end for today's video. So I hope you like this IMO question solving. If you have liked my content, do like, share and subscribe guys. Any doubts, always welcome to come into the comment section. And guys, I have also created a Telegram broadcast group, so and trying to upload a lot of stuff there, like it's already full and a lot of crazy things, questions being uploaded daily. So if you want to come for a good practice, then do join my group. Okay, anyways, that's it for today guys, and thanks for watching.